Okay, at the end of the last video, we talked a little bit about what the identity is. For a 2 by 2 matrix, it's this thing, because if you multiply any matrix by this, you get the same matrix back. For a 3 by 3, it's one extra row with ones all the way down. If you remember when we were solving the matrices a while back, this is supposed to be what we were trying to get on the left side, right? Ones all the way down in the diagonals and zeros everywhere else. So, when we're on page 4, and it says, given A and B show their inverses, I need to show that A times B gives me this identity, and B times A also gives me the identity. So now we know, and this is problem number 3 on page 4, A is 1, 2, 4, 6, B is -3, 1, 2, -1/2. So if I multiply A times B, 1 times -3 plus 2 times 2 equals 1. 1 times 1 plus 2 times -1/2. This is 1 plus -1, which is 0. 4 times -3 plus 6 times 2. That's -12 plus 12, which is 0. And 4 times 1 plus 6 times -1/2. That's 4 plus -3, which is 1. So that confirms A times B is the identity, but I need to also do B times A just to make sure. That would be -3 times 1 plus 1 times 4, which is 1. -3 times 1, or -3, times 2, plus 1 times 6, that's -6 plus 6, which is 0. 2 times 1, plus -1/2 times 4, that's 2 plus -2, which is 0. And lastly, 2 times 2 plus -1/2 times 6, that's 4 plus -3, which is 1. They're both the identity, which means they are inverses. But it would be nice to be able to find the inverse without having to do that. When you just have one matrix, you're not often going to be given the inverse. And this can be done using row operations. So how could I have found the inverse of 1, 2, 4, 6? I make a matrix with the identity across from it. Your goal is to turn the left side into the identity using row operations. And then the right side will then become your inverse. So what am I supposed to do with row operations? I need to get the diagonals to 1 and the other things to 0. Now my top left diagonal is already 1, so I need to turn this into a 0. And I do that by taking row 2 and subtracting 4 row 1s. How does that work? 4 minus 4. Remember, the first row doesn't change. 4 minus 4 is 0. 4 times 2 is 8. 6 minus 8 is -2. 0 minus 4 is -4. 1. Now, I finished this column. Now I need to turn this number into a 1. So now I need to take row 2 and divide it by -2. So again, the first row is not going to change. This becomes 0, 1. -4 divided by -2 is 2. 1 divided by -2 is -1/2. And then the last thing I have to do is 0 out this number, 2. So I need to take row 1 and subtract 2 row 2s. That should get me to 1, 0, 0, 1. The second row should not change. 1 minus 2, 2, so 1 minus 4 is -3. 0 minus 2, -1/2, so -2 times -1/2 is +1, so 0 plus 1, so it's -3, 1, 2, -1/2. Notice this is the exact matrix for B. Now that this is the identity, this is our inverse. So we already knew that was going to happen though, because we already knew the inverse in the problem. So let's try number 4 on page 5. Which is finding the inverse of 2, 4, 1, and negative 1. So I'm going to do the same thing. Put it up against the identity. I need to divide this. I need to get it to 1. So I need to divide it by 2. So row 1 divided by 2. 1, 2, 1/2, 0, 1, negative 1, 0, 1. I have to zero out the row, so I need to do row 2 minus row 1. So again, row 1 stays the same. 1 minus 1 is 0. Negative 1 minus 2 is negative 3. 0 minus 1/2 is negative 1/2. And 1 minus 0 is 0. I need to turn this row into a 1, so I need to take row 2 and divide it by negative 3. Top row stays the same. This becomes 0, 1. Negative 1/2 divided by negative 3 is positive 1/6. This is negative 1/3. And then finally, I've got to zero out this last number here. So this would be row 1 minus 2 row 2s to get my answer. Again, this bottom row is not going to change. Okay, so row 1 minus 2 row 2 is 1/2 minus 2 1/6 is. Okay, so that'd be 3/6 minus 2/6, which is 1/6. 0 minus 2 negative 1/3. So 0 minus negative 2/3 is positive 2/3. So my identity is here, which means this matrix is my inverse. One-sixth, 1/6, 2/3, negative 1/3 is the inverse. So there's also an inverse of a 3 by 3, which I'm going to change the problem. So the one that's on there is a little broken on page 6, so I'm going to give you a new problem, just change the last row, and then we'll do that one in the last video for 6.5.